Hey grade 12s, today we're going to take a look at the equations of sinusoidal functions. We're going to take a look at two special sinusoidal functions. We're going to take a look at y equals sine x and y equals cosine x. We will start with sine x. On the graph of sine x there are 5 key points, and we're going to take a look at all 5 of those key points. The first point that's key is the very beginning. Then we have point B, that is the maximum value of the function. The third point is point C, and it has the same y value as A, and it's also halfway through the journey. You see the sine curve goes up and then it comes back down. When it reaches the same y value as it started at, it is halfway through its journey. At point D, the function comes down and hits the minimum value before returning back at the same y value at point E. So we see that the sine curve goes up, comes down, goes all the way down, and then comes back up. Alright? Those are the 5 key points of the sine curve. Now, we'll take a look at the 5 key points of the cosine curve. It basically looks very similar to the sine curve, except it starts at the top and then it comes down to the middle and down all the way halfway through and then works its way back up to the top to finish off. Okay? We have talked about horizontal translations. Picture a parabola. If we take the parabola and shift it to the left or the right, that is a horizontal shift. And really, the sine and cosine curves, one can be generated from the other by a horizontal shift. Okay? So, let's take a look at some more information. The sine function can be written in the form y equals a times sine times b times x minus c plus d. And usually this whole thing, especially if we're working with it on the graphing calculator, this whole thing there is in brackets. Likewise for the cosine, it's the exact same thing. The cosine function is the exact same in appearance as far as the variables a, b, c, and d go. Now, what do the a, b, c, and d values do? A represents the amplitude, okay? That influences the vertical height of the graph. B influences the period. That is how long it takes before the graph starts to repeat itself. C influences the horizontal position. The C value will shift the graph left or right depending on what that C value is. And D is the median line or the vertical middle of the graph. The period of sine x or cos x is always 2 pi. Now, it's always 2 pi for the base function sine x and the base function cos x. If we change the b value, it changes the period. And depending on what that b value is, we can find the period by taking 2 pi and dividing it by b. Okay? Alright. So, let's get down to business here. We've got some graphs. Let's figure out how to find the equation of the graphs. So, I've got this big graph here, and when I'm going to try and find the equation of this graph, what's the best thing to do? The best thing to do is to figure out the d value. That is the vertical middle. So what I'm going to do here is I'm going to consider this line. What do I want to do here? Yeah, I want to go right here. I want to go right here. Because this purple line that I've drawn is the vertical middle of the graph. And that tells me right there that d equals -4. Alright? Now, What's A? Because that's actually the next thing we should figure out. Well, of course, A is the height between the vertical middle and the top of the graph, and that is 1, 2, 3, 4 units. So in this particular case, A is also 4. They're not usually the same, but they are in this case. Okay? So D and A are the easiest to find from a graph. Then we'll worry about B and C. Okay? We'll think about B first. I guess we can. Now, let's see how long it takes before this graph starts to repeat itself. So, I'm going to get my highlighter ready here. Going to go up, going to come down, then I'm going to come back up. I've got one full period is at 2 pi. Now, that's the standard. That is the standard. So, if the period is 2 pi, B is always 1. If the period is 2 pi, B is always 1. So B is 1 here. Okay? So B equals 1. Okay. Now, we need to consider what C is. Now, the standard sine graph starts in the middle and then starts to go up. So we got to see where our graph starts. Our graph starts in the middle and then starts going up. So C is 0 because it has not shifted from the position that it usually starts at. If it started at the top or started at the bottom, then we would say that there was some kind of a horizontal shift, some C value. But since it starts where it's supposed to and starts going up like it should, there's no C value other than 0 here. So we have figured out A, B, C, and D. So then we can go ahead and write the equation as y equals A, which is 4, sine B, which is 1, so we don't have to write it, x minus C, which is 0, so it's sine x minus 4. That's the equation of that graph. So we have to look at this in a systematic way, starting with the D value, then thinking about the A value, then going to the B value, and then the C value. Okay? All right, let's do another one. So, I'm going to take this new graph here, going to move her down, and okay. So first step, find the vertical middle. So the vertical middle here is going to be right here. Do I like that? 1, 2, 3, yep. 1, 2, 3, yep. So D is -2. A goes from -2 up to 1, so that's 3. So then we're just thinking about B and C. So we got to figure out how long this graph goes before it starts to repeat itself. So, let's go. Up, down, come back up. That's one full period. One full period is at pi. So we do have a B value this time other than 1. So to find it, we do use that formula. Period is equal to 2 pi over B. We know the period is pi.
Good morning, everyone. It's 5 after 9. Let's get up and at it and head into school, please.
If we want to find out what B is, we have to just solve this equation, knowing that that period's pi. So if I just rewrite this equation by doing some cross multiplying, 2 pi divided by pi is 2. So B is 2. So B is 2. Okay? And C, again, we have to look at what the graph's doing. It's starting at the middle line. It's going up. That's how sine should start. So C is 0 here. So the equation's in the form y equals A is 3 sine of 2. And then there's no C value, so that'd just be x minus 2. Okay? So the equation of that line, or rather the equation of that periodic function is y equals 3 sine 2x minus 2. I said off the top that sine x and cosine x are very closely related. that one was just a vertical translation away from the other one. So any of these graphs that we come up with sine equations for, we could come up with cosine equations for them. And likewise, if we find a cosine equation to match a graph, we can also come up with a corresponding sine one as well. The only difference would be the c value. Okay. Next example here, we've got the equations of the graphs below. So again, same idea. First step, find that vertical middle. So vertical middle here, a little tricky to find. This one's not as easy. Okay. We are raising the stakes a wee bit here. Okay. So here I go. There's my vertical middle right there. Okay. And I can double check it. I've got 1, 2, 3, 4, 5 units above and 1, 2, 3, 4, 5 units below. Okay. So that is the vertical middle. So I've got D equals negative 140. A would be the distance from there. A be 100. That's 100, not 1,000. So there we go. Good. Now we got to worry about the B value and the C value. The B value is interesting because what I see here is, I want to talk about what we see here. We see a graph that starts here, comes down, goes all the way back up, and then stops. Okay? So based on that actually, like that shape, starting at the top, coming down, going back up, that looks like a cosine curve. Now, granted, like I said, we could come up with a sine curve or a cosine curve, but if that exactly looks like the cosine curve, I'm going to make this easy on myself, and I'm going to make this a cosine equation. Okay? Now, sometimes we'll have a choice, and sometimes we'll just be asked to find the equation. And if we're asked to find the equation, then it's free for us to make up our own mind. But I'm going to go with the cosine here. But what I see here is that it goes through one full period at 4 pi. So I have to use that formula. That period equals 2 pi over b. The period's 4 pi. We don't know the b value, but we can figure it out. So b is going to be 2 pi over 4 pi. So b is going to be a half. So over here, b is a half. And c, like I said, is dependent on whether we're looking at this as a sine or a cosine function. If I look at this as a cosine function, then c is actually 0 because it starts exactly where the cosine curve starts. So now that we have all those things, we can build our equation here. We've got y equals a, so that's 100, cos, because we're using the cos equation this time, b is a half, so that's half, x, c is 0 again, so plus d, so that's minus 140. Okay? So that would be that equation right there. Let's do another one. Okay, so again, the first step is to figure out that vertical middle. So where's that vertical middle going to be? Vertical middle is going to be right here. So looking at this, looks like my D value is going to be 36. A is going to be 48. I still have to figure out now whether I'm going to do a sine or a cosine here. I'm actually going to do a sine one this time. Okay, I could do cosine. I'm going to do a sine one this time. So if I'm doing sine, I know sine. How does sine go? Well, sine goes like this, right? Sine goes. Okay. So what I see here is that this function should start at the middle and go up. But in fact, it starts at the middle and goes down. So what's happened here is a shift. Okay? A shift of half the period. We'll talk about that in just a minute, though, because we don't know what our period is in this question. We know it's half a period. Okay? So I'm going to write that down so we don't lose ourselves here. Okay? So what is the period? Well, if I look at this, the period is going to go, well, we start here, go down, come all the way back up, and then we come down and stop right there at 40. We stop at 40. So using that formula that we have, we know that the period is equal to 2 pi over b. We know the period's 40. Nothing in terms of pi, but 40. So what's b going to be? Well, if we rearrange, b is actually 2 pi over 40. We don't figure it out as a decimal. Just 2 pi over 40 is sufficient. And in fact, in many application questions that we might do, our b value is probably going to be something like this, 2 pi over something. Okay? Now, good enough. So, what is our c value going to be now? Because here's what I see. I see that our graph, our normal graph, got moved over 20 units. 20 units. Okay? So, what we have to understand is because it got moved 20 units to the right, our c value here is going to be 20. Okay? Our c value is going to be 20. Because at the x value of 20, it's starting in the middle, and it's going all the way up and coming all the way down, blah, blah, blah. So with our equation, it's going to be in the form y equals a. A is 48. Sine. Our b value is 2 pi over 40. Then we just put brackets, because we do have a c value this time. X minus 20 plus 48. Oops. Plus 36, not 48. Make a little correction there. There we go. Now, before we finish this one off, why is it minus 20? Remember when we did quadratics back in grade 11. Inside the bracket, if it was x minus 2 or x minus 4 or x minus 6, it meant we moved to the right that many units. And if you look back at the general form of the sine function that we defined in this lesson, you'll see that it was x minus c. So because it starts its normal journey at 20, it's like we move the graph 20 units to the right. So that's why it's x minus 20, not x plus 20. Okay? All right. Now, is that it? That's all? Yes, that's it. That's all. So, a few takeaways here, just as we finish off this lesson. Unless you're otherwise told, you can use sine or cosine for any of these graphs. The only thing that's going to change is your c value. D, A, and B are going to all be the same. You should find D first, then A second, B third, and then C fourth. I guess you could find C before B, but generally speaking, D, A, B, C is probably the best way of doing this. Okay? When you have figured out your equation, feel welcome to graph it with a graphing calculator or Desmos and see if you get the exact same thing you have on paper. If you do, fantastic, give yourself a hand. If not, see where you made a mistake. Okay? Finding the equation is not that bad, but it does take a while to get used to. It does take a while to get used to the fractional pies as well, which you're not used to. Okay? All right. So you'll be getting a homework assignment on this. give that a try, and then next class, I believe we'll be actually graphing the functions. We'll be given the equation and we'll be graphing them.